Okay, welcome to this video on isotopes. Just going to give you a brief reminder of how we can calculate the protons, electrons and neutrons for any element using the periodic table, and then go straight into isotopes from there. So, as you can see here, just where I'm highlighting, we have got a breakdown of one of the elements, and this element is helium. So, as you can see on the periodic table and from this this diagram that I've got here, we've got helium with a mass number of 4 and an atomic number of 2. Now, how we work these out for any element, so this is the same process for absolutely any element, we need to work out 3 things. Okay, one is our protons, one is our electrons, and one is our neutrons. So the first thing that we do, to work out our number of protons, it is the same as this number here, our atomic number. So our atomic number is also known as the proton number, and if you've got 2, then that means that you have 2 protons. Now, in any element, to work out the number of electrons, it's for all atoms, so for any element here on a periodic table, there is no overall charge, and what that means is that the protons and the electrons are equal to each other. That means that the protons, the positives, and the electrons, the negatives, have the same amount and therefore cancel out that charge. So that means that if you've got 2 protons, you have to have 2 electrons. Now, to work out neutrons, it's very, very simple. Our mass number, which you would have seen from previous videos, is our nucleus. Okay, so that our mass is the mass of the atom is centralized in the center of the atom in the nucleus. So if we've got a mass number of 4, that is our protons and our neutrons added together. Now, if we have our protons, but we need to calculate our number of neutrons, what we do is we take our number of protons, okay, so as we said, is 2, and we subtract that from the overall mass number, which is our nucleus, and whatever number is left behind is the number of neutrons. So in this instance, mass number of 4 minus the protons away, which is 2, leaves us with 2 neutrons, okay? Really, really important to remember that. Very, very important to bear in mind that the proton number, the atomic number, tells us what element it is. So if there are 2 protons present, then that element has to be helium. If there is 3 protons present, then that element has to be lithium. Okay, that's as straightforward as I can make it for you there. Now, just moving down to talk about isotopes. So I've put a definition here for you just to make it nice and clear. And that definition, as you can see, is an atom. So an isotope is an atom of the same element with the same number of protons, but a different number of neutrons. Okay, so the same number of protons, because as I've just said to you, if an element has 2 protons, for example, it has to be helium. If it has 3 protons, it has to be lithium. But it can have a different number of neutrons, which would mean its mass number is different. So just to look at this example here, there's 3 isotopes of hydrogen, okay? So I've got those 3 here, okay? Now, we can have a look at these diagrams and very simply work out which are the isotopes of it. So if we look back at the periodic table, so if I just scroll up here and we look at hydrogen, we've got a mass number of 1 and a proton number, an atomic number of 1 as well. So really simply, we can see that this here is the one that we can see there on the periodic table. And then we've got deuterium and we've got tritium as well, who are, these are the isotopes of that. Now, potential questions you could get asked is to work out which one are the isotopes, or you could get asked what are the mass numbers, for example. And it's very simple for us to work that out. It's the same process as we've just looked at. So, looking at this one here, really simply, we can see that there is 1 proton here in the center, okay, in that nucleus. Now, we haven't got any neutrons there, so we don't have any neutrons that we need to think about, okay? So this is the one that's on the periodic table of hydrogen. Now, if we look across to deuterium, which is this one here, okay, we've got proton and we've got a neutron in the center. So this one, if we're looking at it, as you can see here, the mass number is 1, and the proton number would be 1. Now, looking at deuterium here, well, we've got a mass number of 2. So I'm just going to jot that in here. So again, hydrogen is the symbol. A mass number of 2. And if we look at what our atomic number would be, it's going to be, we've only got 1 proton, it's going to be a 1. Okay, now moving on to tritium here. So same process applies. We've got our proton in the center, okay, which we're aware of already. So I'll just drop that in just to remind you, because if it's hydrogen, it has one proton. But then to work out our mass number, okay, which is already stated here, okay, so nice and simple, but our mass number, we just add up what's in the nucleus. So we've got a proton and we've got 2 neutrons. So that means the mass number would be 3. All of these are hydrogen, but they are isotopes of hydrogen, and these two in particular are ones that you don't see on the periodic table. This is the one on the periodic table. These two aren't on the periodic table, but nonetheless, they are still isotopes of hydrogen. So moving down, just to look at another example here. So we've got carbon-12, we've got carbon-13, and carbon-14. So going back to the periodic table just briefly, you'll have a look here. If you look at carbon, you'll notice that carbon here has 12 for its mass number and 6 for its atomic number. So the one that we see on the periodic table is this one here, carbon-12. Now, really simply, same process applies. All that we're seeing here, or all that we're stating, and again, you could even work it out like this. So we can do protons, electrons, neutrons for all three. So we can do C12, C13, and C14. And we can work it out really simply. So if we look across, we know that if it's carbon, based on the periodic table, it has to have 6 protons. So they all have 6. Now, again, in an atom, the protons are positive, the electrons are negative. They have to cancel out that charge. So that means we've got 6 electrons as well. Now, all we do, as we said previously, is we look at our mass number, we minus our atomic number, and what's left is our neutrons. So, because we know that this is, our proton number is 6 for all of these, if we do 12 minus 6, then for carbon-12, we have 6 neutrons. Now, we can see the mass number on carbon-13 is different. Okay, we've got carbon-13. So what we have here, we're doing 13, the mass number, minus 6, because again, the atomic number doesn't change, and that leaves us with 7 neutrons. And on carbon-14, okay, our mass number, once again, we have 14 as our mass number, we minus 6 from it, and that leaves us with 8 neutrons. So, just to go back up to our definition. As you can see here, the definition, an atom of the same element, and that's really important to bear in mind, okay, with the same number of protons, that tells us that they're the same element, same number of protons, but they have a different number of neutrons. Okay, so just to go down again, atoms of the same element, as you can see here, same number of protons, a different number of neutrons, hence why the mass number is different. And exactly the same on this example here. We've got the same, so same element, carbon, same number of protons, but as you can clearly see, there is a different number of neutrons present, hence why the mass number is different there. Any questions, let me know. Good luck. Thank you.